Modems. The word modem is really just made up of modulator and demodulator. That is what we use for our internet connections. Regardless if you have DSL, fiber, cable modem, it is still a modem. And there are probably still a few dial-up modems out there. With dial-up modems, we take the binary data and we modulate it into analog sound. Then we send the sound over the phone network, and then the receiving modem demodulates the analog sound into binary data. Not so commonly used anymore, but probably still around. What is more commonly used is ADSL modems and cable modems, and if you're lucky, fiber modems. ADSL is an abbreviation of asymmetric digital subscriber line, and they use the normal phone cables to carry signals, but they use much higher frequencies than the normal cable's frequency rating. And a lot of places, if you're still using a landline as well as the ADSL connection, you would need some sort of filter to ensure that the higher frequency data transfer doesn't interfere with the voice conversations. And you already know, copper cables have attenuation. If you're within half a mile of the central, you might get 20 megabits. If you're a couple of miles away, you might get 1 or 2. And if you're 3 or 4 miles away, maybe even 5, you may or may not be able to get a connection. The signal strength drops, and that is the attenuation. Cable modems are the ones using the coax cables. They are originally designed to carry TV signals, and because of that, they were designed with the higher frequency already. But most of them today can either be an internet connection, a TV connection, or both. And they can do so without needing that filter like the DSL connection needed. There is no interference, because the different traffic is in different frequencies. Like I said, if you're lucky, you might also have a fiber modem. That's just the ISP running fiber all the way up to your door, and then you can get crazy high speeds, because fiber does not have attenuation. If you're on the other spectrum of that, you live in the middle of nowhere. Even copper can't carry a signal to you. You might still be able to get some sort of interconnection with a satellite modem. I mean, not crazy fast speeds, but you still have internet access. And then finally, powerline modems. They are very new. I haven't seen them in a lot of places, but I have seen them. Data signal sent over the power lines, then you plug your modem in and it gives you an internet connection. I don't see a lot of the ISPs really going in that direction, but who knows. When we talk about modems, we have DTEs and DCEs. The DTE, or the data terminal equipment, is what we normally call a client. That's your desktop, your server. The DCE, or the data circuit terminating equipment, that would most often be the modem. That's your connection link between your inside device, the DTE, and the data transmission circuit, or just your internet connection. The DCE does all the signal conversion, clocking. A lot of times this is where the ISP's network ends, and you have a connection to the DTE, and that is your network. But that is mostly legacy. If you're thinking about your home network, you don't have 2 boxes. Well, I hope at least you don't. You have the modem that your ISP gave you, or one that you bought. In some businesses, you can probably still find DTEs and DCEs. In some older router configuration, you do the same. The ISP will come, bring you a router, will be the DCE, it connected to your router, the DTE, and then they will be synchronized. They would agreed on protocols, clock cycles, all set by the DCE, and if they were agreeing on that, the connection would be established. This is also where the demarc is. The demarcation between the ISP and your equipment, where their responsibility stops and yours begins.